Hi everybody. We're going to do some more with graphing functions today. We're going to look at the different parts of it. Just remember this is Unit 5, Lesson 6. All right, so a little bit of vocab for you. The maximum, remember, is the very top of the graph. It's technically your largest output or your largest y value. But again, the easiest way to figure it out is to find the very top point. The minimum is the opposite of that. That's going to be the bottom of your graph, the very lowest point. But again, technically, it's the smallest y value. Okay, y-intercept. If you intercept a ball, you are coming into contact with the ball. If you intercept the y-axis, it's where it crosses, your function crosses the y-axis. And remember, your y-axis is your vertical axis. So if you see your function going like that, this point right here is going to be your y-intercept. Your zeros we actually talked about when we were factoring. I know you don't want to hear that term again, but they're also called x-intercepts because it intersects or intercepts the y-axis, or excuse me, the x-axis. So this would be considered a 0. This would be considered a 0. They're also called roots because I want you to think of this as the ground. The x-axis is the ground, where it's rooted to the ground, where it goes into the ground. Those are your zeros, your x-intercepts. All right, turning points are where your graph turns. All right, so if you see something like this, right here would be a turning point, here would be a turning point, here would be a turning point, and here would be a turning point. All right, so if it's increasing and then it turns and decreases, that's a turning point. All right, something like this, that's not a turning point because it didn't turn, it's still decreasing. Okay? All right, so let's identify some of these things on the graph. So this first function is function f. Remember, this is just giving it a name. Okay, we don't have an equation. And it's over the interval -7 to 7 on your x-axis. So if I were to make a table, my x's would go from -7 to 7. But on the graph, they go from -7 to 7. All right, so that's the width of your graph. Find the max and the min values. So the max, and it's helpful to label, is the very top. So this is the very top point right there. So that's your max. And the very bottom point is down here. There's your min. All right, so our max looks like it gets up to 1, 2, 3, 4, 5. If you wanted to state that point, it would be the point -1,5. The min, the very bottom value that it gets to, that very bottom point, it's 3 below ground, so it's -3. And if you wanted that actual point, it would be the point -1, 2, 3, 4, -5, -3. All right, so max is the top, min is the bottom. The y-intercept, okay, here's your y-axis right here. So where's it crossing the y-axis? Right there. There's your y-intercept. All right, and where's it hitting the y-axis? At 1, 2, 3, 4. Or you could write it as the point 0, 4. But typically, you're just going to write that value. How many zeros does the function have? So how many times does it hit the ground? All right, let me change up the color on us here. So zeros would be here. I'll put a little O there for 0. So there's 1, 2, 3, 4 zeros. Remember, they're called zeros because they have a height of 0. They're also called roots because that's where it's rooted to the ground. All right, list all the turning points. All right, so let me change up the color yet again here. Why don't we go with purple? We already have one that's like that. We'll go with black. All right, so I'm going to have you label them with a star so they're easy to see. So right here, it's turning. So that's a turning point. That's the point -5, -3. All right, and then you can see it goes up, 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 and then it turns right here at that max. So that's a turning point up here. That was the point -1, 5. Right? Because you went back 1 up 5. And then it's decreasing. Oh, right here it turns. There's another turning point. It also happens to be one of your zeros. That's the point 2, 0. And then finally, up here is where your last turning point is. This is not a turning point, and this is not a turning point. That's just the end. Where did our graph turn? So that's the point 2, 4, 5, 3. Okay? Would you characterize the function as increasing or decreasing on the interval from -5 to -1 on our x's? Now, increasing, you're going to see it going up from left to right. Decreasing, you'll see it going down. So let's just zoom in on that part. All right, so we want to look at, oops, I don't want a signature. Let's see. Let me change up the color again. All right, so I want to look at between -5 and -1 on the x's. So your x's, your x-axis is here. So -5, -1, -2, -3, -4, -5. So from here to here, in that range right there, I wish I had a highlighter. Of course, I'll find it after, but that's okay. So from here to here, we want to look at what's happening to our graph. So on here on the x-axis until we get to -1, does that appear to be going up or down from left to right? It's increasing. So that is going to be characterized as an increase because it's going up. Okay, let's look at one more example on page 17. All right, so remember, function notation, if you see this, it's the same as writing the point x, y. All right, so this right here, -7's in the parentheses. It's -7, comma, something. So find where -7 is on your graph. 1, 2, 3, 4, 5, 6, 7. -7, and then follow it up or down until you hit it. Right there. It's the point -7, -2, 4, -6. So f of -7 is -6. All right. F of 0, that means you don't go from side to side. Followed up, there's your y-intercept too. So that's the point 0, 3. You don't have to write it as a point, but using function notation, that's what they're doing. They're asking you, what's the y value when the x is 0? What's the y value when your x is 4? All right, go to 4. 1, 2, 3, 4. What's the y value right there? 1. So that's the point 4, 1. Again, you don't have to write the point, but all right, and then 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Follow it down to here, -4. All right, for how many values of x does the y value equal 5? So the easiest way to think about that one is to find where the height is 5. So you want to find 5 on the y-axis. 1, 2, 3, 4, 5. So anything that goes from here over has a y value of 5. So like this has a y value of 5. This has a y value of 5. This has a y value of 5, right? That's the 0.15, 25, I don't know, negative 95. All right, there's 3 values that hit f of x equals 5. What's the y-intercept? We just talked about that, where it crosses the y-axis. That's going to be the 0.03, or you could just say the y-intercept is 3. How many zeros does it have? Again, where is the height 0? Let's change up the color again. So, where is the height 0? Right here. 2, 3, and don't forget that guy over there. There's 4 zeros. Okay? State the max and the min. Okay, remember the max is the very, very top, so let's find that one first. Way up here. There's your max, way up there. And that has a height of 1, 2, 3, 4, 5, 6. And the min, looks like the lowest point is way down here. There's your min. And that has a height of negative 6. Okay, you're not looking at the x value where it happened. You want to say how far is it above or below the x-axis, above or below the ground. So your max equals 6 and your min equals negative 6. A couple more. It says to list all the turning points. There's a lot of them. So instead of listing them, let's mark them with a star and state how many. Okay, so here's a turning point. There's 1. Right there. 2. Right here. 3. 4. 5. 6. And 7. There's 7 turning points. Okay, mark them all with a star. So it's not the beginning and end. It's where it's decreasing and then it turns and goes the opposite way. Explain why the graph represents a function. Because it passes the vertical line test. There's nowhere on here, if you saw something like, if you saw a graph like this, that would fail the vertical line test, right? Because I could draw a vertical line right here, and it crosses 1, 2, 3, 4 times. Remember, if you can draw a vertical line anywhere on here and it's only going to cross once, it's a function. So this is a function. Each x has 1 y. Each person has 1 birthday. So it passes the vertical line test. Each person, which we'll cross out and put an x, each x has 1 birthday. And we'll cross it out and put a y. Each person has 1 birthday. Each x has only 1 y. So you're good. State an interval over which the function is decreasing. So intervals are kind of funky, but it's going, why don't we go from here to here? Or here to here. It's going down. So with the intervals, this part gets a little tricky. It's talking about what x values make that happen. So right here, between here and here, our function is decreasing that whole time. So between, let's say, 1, 2, 3, 4, 5, 6 to 9. The whole time when you're between 6 and 9. So starting here at 6, 7, 8, 9. You're not looking at the height. You're looking at between here and here. All right, so between 6 and 9 on your x-axis, it's decreasing. And you can just write it using your interval notation between 6 and 9. I know that part's kind of tricky. Not going to be tested on that, but it is something that you'll see pop up from time to time. Okay, so that's it for lesson 6. There's going to be a practice page. Use this to help you along if you have questions. Stop by either my virtual math lab that I have every day or stop by during your class period. I'd be happy to help you. Have a great day.